Alright, so we're back in the world of redox. And yesterday we learned about a little acronym called OILRIG, which stands for oxidation is loss of electrons and reduction is gain. So the types of reactions we saw yesterday looked a little something like this. And these are called half equations because they show half of what's going on in the reaction. So this one, where the electrons are lost from the start to the finish, of the reaction, this is the oxidation reaction. And that means that the substance at the start of the reaction is called the reductant or the reducing agent. And then this reaction here, wait, it's a bit messy, put a thumb a plus. All right, so this one where electrons are gained at the start, this is the reduction, and that makes the Zn plus the reductant. But sometimes it's not so easy to tell through a half equation what's happening. Is it oxidation, is it reduction? Especially when there are polyatomic ions. So today we are going to be looking at oxidation. This was meant to be like a dramatic zoom out, so all of you will be like, whoa, she was actually writing on the page. Oxidation numbers. So let's write some notes on this. So oxidation numbers are numbers that we classify each element in a reaction by, and by seeing the changes in oxidation numbers from the start of the reaction to the end of the reaction, we can identify if that element has undergone oxidation or reduction. So there are a couple key rules. It seems like it's a bit annoying to learn, but these are ones we're going to have to learn by heart. And the more you practice, the more you'll get used to them. And just as a hint, when you see ON, that stands for oxidation numbers. So the first thing to know is that when you see a free element, the oxidation number is 0. So if you just see magnesium as a solid, its oxidation number is 0. If you see oxygen as a gas, plain oxygen, it is a 0. If you see an ionic compound though, the oxidation number would equal the charges on the ion. So if you see something like, aluminium oxide, we know aluminium normally has a charge of +3, and oxygen normally has a charge of 2- as an ion. So that means the aluminium here has an oxidation number of +3, and the oxygen has an oxidation number of -2. I should write -2, not 2-. Whoopsie-doo. So yes, the other way around, guys, just watch out for that. So this is why learning your ions is so important. It keeps coming up in all areas of chemistry. Hydrogens, whenever you see hydrogens, its oxidation number is +1, except in metal hydrides, that's its only exception. Oh, not an attractive highlighting color. Here we go. Ooh, it kind of covers it. That's kind of cool. And oxygen has an oxidation number of -2, except when it is in a peroxide. Peroxide is when there is a O2, and then it'll be a -1. Sorry, I should have said that for the hydrogen as well. In neutral compounds, the oxidation numbers will add up to 0, and when it's an ion, like a polyatomic ion, the charges will add up to the ion. So let's try hydrogen. Hydrogen is a neutral compound. It doesn't have a charge. The charges on hydrogen is +1, but since there are 2 hydrogens, it's going to be 2 times +1, and the oxygen's -2. 2 times 1 plus -2, 0. Can you see how it neutralizes out? And for ions, let's come up with an ion. All right, here's an ion, hydroxide. We know the charge on the oxygen is -2, the charge on the hydrogen is +1, and that equals -1. Oh, fancy that, the same charge as the ion. Also, last rule, when electric negative atoms, such as these, are combined, the most electronegative atom or element takes the oxidation number equal to the charge on its ions, and here's the order. But we don't really use that too often, but I'll show you some examples where we will. Alright, so there's actually no textbook exercise on oxidation numbers. This is actually preparing you for next year. So just something a little bit extra we do. So I'm going to do the following 3 on this page, and then the ones on the next page are going to be for you to try yourself and check the answers on the answer booklet, which is on Schoolbox. So we have potassium phosphate. Alright, so this is a neutral compound here. So the aim is for everything to add up to 0. So the first thing we're going to work on is the K. The K, the potassium, has a charge of +1. There's 3 of them, so this is going to be 3 plus 3 times +1, which is going to equal +3. So here the K, overall, potassium has an oxidation number of +3. Now, we're looking at the PO4, but remember oxidation numbers are each element gets a number. So let's actually look at the oxygen. Oxygen's the one we know. The rule for oxygen is that it's always -2, except if it's in a peroxide, but this isn't a peroxide. However, there's 4 of them. So this means it's going to be -2 times 4, -8 for the oxygen. Now, the P for the phosphate is what we don't know. Phosphorus. So we know all of this adds up to 0. So whatever the phosphate is going to help us add up to 0. So we've got +3 minus 8, so we're at -5 plus P equals 0. So that means potassium. Phosphorus is 5. So yay. That's our answer. We would just say K equals +3, phosphorus equals 5, and oxygen equals actually, you would just put -2, yeah? Don't write -8. You have to write what the individual oxidation number is. You have to do all that adding up to find the last part. So, to clarify, make it super clear for you, potassium is +1, phosphorus is +5, and oxygen is -2, and that's how you'd solve that one. Alright, next year we have got a charged compound, so everything's going to add up to -2. Start with oxygen. We know that oxygen has an oxidation number of -2. So in here, this is -2 times 3, which is -6. So we know oxygen's oxidation number, but this is -6. So -6 plus 2 of the sulfur is going to equal -2. Alright, so 2 of the sulfur is going to be 4. That means sulfur must have a oxidation number of +2. So there's our answer. Oxygen has -2 and sulfur has +2, because when you put these together, it'll add up to -2. Here's one where we have 2 electronegative atoms. We've got oxygen and fluorine, but fluorine takes preference over Cl, and the charge of a fluorine ion, the fluoride, is -1. So fluoride is -1, and this is neutral. So that means that, overall this is -1 times 2, because we have 2 fluorides. So that means oxygen -2 is going to equal 0. So what is going to balance out this? Oxygen has got to be 2. So that means the oxidation number on fluoride is -1, and the oxidation number on oxygen is 2. Oh wow, I wrote that really tiny. So yeah, pause, rewind if you didn't get that down. Alright, so just to note, oxidation numbers are just numbers. They don't have meanings. It's just to help us classify where oxidation is happening and reduction is happening. The charges on the ions are real though, and when writing oxidation numbers, the numbers refer to each individual atom. So please be careful. I know when there were times like a O2, we were doing like -2 times 2. But at the end of the day, the oxidation number of one oxygen is -2. So just watch out for that. My dogs come to visit. Anyway, so give these ones a try. There are 8 of them to practice, and have a look at the answers. And if you're stuck, come in and visit and I'll help you through. There's still something more to look at though, so just keep going in the video. Alright, so if the oxidation number increases of an element between, the left to the right side, if it increases, that means it's oxidized. And if it decreases, it is reduced. So actually that's really helpful if you're getting confused with the whole oxidation is loss, reduction is gain. If the oxidation number is reduced, it's a reduction reaction. So let's put this into action. We have a reaction here to have a look at. I'm going to highlight it in yellow. And let's calculate the oxidation numbers. Maybe I'm going to zoom in for this. All right, so let's write this reaction down. We have got iron oxide plus carbon monoxide goes to plain iron plus CO2. The big numbers in the front actually don't matter when we're doing oxidation numbers, so scratch that. All right, let's focus on what we know. We know oxygen is going to be -2. So let's put that. The oxidation number is -2, unless it's in a peroxide, but we have no peroxides. All right, but here we have 3 oxygens for this first reactant. So it's going to be -2 times 3, which is going to equal -6. So whatever the oxidation number of the iron is, it's got to balance out this -6. So Fe, 2 Fe's -6 equals 0. I'm just solving this like an algebraic equation. So divide both sides by 2. So the oxidation number of iron is +3. Nice. Whoopsies. Let's highlight. All right, now for the oxygen here, we already know it's -2. And this is going to balance out to 0 because it's a neutral substance. So what will carbon be? It'll be +2. +2 minus 2 equals 0. Let's highlight them there. All right, so let's focus on the other side. We have a plain Fe. That means that the oxidation number is 0 of Fe now. And let's look at this side here. We've got the -2 for the oxygen, but there's 2 of them. So we've got 2 times -2 equals -4. So whatever the carbon is, it's going to balance out to 0. That means this is +4. Because +4 minus 2 equals 0. So the carbon is +4 and the oxygen is -2. So let's start with reduction. Reduction is where the number decreased. And the number that decreased is for iron because it was +3 and then it went to 0. So that means it underwent reduction. So Fe is the oxidant. Remember, it does the opposite of the reaction it underwent. Oxidant. Nope, spelled it wrong. Kidding, I spelled it right. No, it was editing. I just want to try all these different features. It's kind of fun. All right, and then we have to look which number increased, and it's actually the carbon. Because the carbon went from +2 to +4. So that means it underwent oxidation. Oh, phones should be off whilst I make videos, hey. Oxidation. So that means that carbon is the reductant. So hopefully that helps get the main points. So the first thing you need to know how to do today is to make oxidation numbers, following the rules that are on that first page we worked on, so oxidation numbers. And then realize that if the oxidation number increases, it's oxidation, aka that substance is the reductant, and if the oxidation number reduces, it underwent reduction. All right, give these questions a go at the bottom of this page. And then, yes, hop in if you have any questions. Remember to check all of these. The answers are on Schoolbox.